Yes, it started, right? Live streaming is already started. Okay. Now, the first step involved in calculating the limiting region is, first of all, we need to write the balanced chemical equation, right? So we need to write the balanced chemical equation. In the second step, we need to write we have to calculate the mole of each compound. So first step, write the balanced chemical equation. Second step, calculate the mole of each compound. And in third step, calculate the ratio of the number of moles to the stoichiometric coefficient, right? So in the second, third step, calculate the ratio of the number of moles to the stoichiometry coefficient. Now, the compound with the minimum ratio will be the limiting region. So the compound which is present in the minimum ratio. So the compound with the minimum ratio will be the called limiting reagent, right? Now, step 4, let's see. So do all the calculation based on the availability of the limiting region, right? So do all the calculation based on the availability of the limiting region. Now, let's see one example. Through example, you can better understand what do you mean by this some limiting region. So suppose we have a 50 kilogram of N2 react with 10 kilogram of H2 to produce ammonia, right? So 50 kilogram of N2 react with 10 kilogram of H2 to form ammonia. Now you have to calculate the amount of NH3 formed, right? So you have to calculate the amount of NH3 formed and also identify the limiting reagent in the production of NH3 in the particular situation, right? So let's see how we'll solve this question. So first of all, we need to write the balance reaction. That is when the N2 react with 3H2, they will form 2NH3. So this is the balance equation. I hope this is clear to everyone that we need to write the balance equation first. That is N2 plus 3H2 gives us 2NH3. Now, in second step, number of moles of each compounds we need to write. That is the number of moles of each compound. For example, moles of N2 is equal to 50 upon 28. Why? Because the mass is already given, right? 50 kilogram of nitrogen. And we all know the molecular mass of N2 is nothing but 28. So this is 50 upon 28. So it comes out to be 17.86 into 10 k power 2 mole. Similarly, the moles of hydrogen comes out to be 4.96 into 10 ki power 3 mole. Now, the next is number of moles versus stoichiometric coefficient. So this is also very important. That is the number of moles versus stoichiometric coefficient. That is N2. So N2 का coefficient कितना है? जल्दी से बताओ. So the coefficient of N2 here is 1 and coefficient of H2 here is 3. So N2 coefficient is 1 and H2 coefficient is 3. So it comes out to be 1.786 into 10 ki power 3. So this value is greater than H2, right? So the values of that is the number of moles according to the stoichiometric coefficient in nitrogen is more as compared to the hydrogen. So we can say that hydrogen is a limiting region, right? So what we can say that hydrogen is a limiting region. कि hydrogen हम लोगों का यहाँ पे limiting region है. So is this clear to everyone? How we'll find the limiting region? Confirm once, everyone. Is this clear? Yes. Yes, sir. Good. So this is how we can actually find the limiting reagent, right? So now in the next step, we have calculation based on the availability of the limiting reagent, right? So let's see. Since 3 mole of H2 produce 2 mole of ammonia, right? This is from the equation. We observe that ki 3 mole of H2 produce 2 mole of ammonia. So 3 mole of H2 produces is equal to 2 mole of ammonia. Therefore, 4.96 into 10 raised to the power 3 mole of H2 will produce this much of ammonia. So the answer is 3.30 into 10 raised to the power 23 mole of ammonia. Now, in terms of mass, how will you calculate? So the mass of NH3 obtained is equal to nothing but just multiply the number of moles with the molecular mass. So that is mole is 3.30 10 raised to the power 3 and multiply with the molecular mass that is 17. So values comes out to be 56.1 kg. So 56.1 kg is absolutely correct answer. ठीक है तो correct answer क्या हो गया हम लोग का 56.1 kg. I hope this is clear to everyone. hmm? Done. Good. So this is the answer, right? That is 56.1 kilogram. So 56.1 kilogram ammonia produced. The amount of ammonia produced is equal to 56.1 kilogram. Now let's see the next one. Chlorine is prepared in the laboratory by treating manganese dioxide, right? Chlorine is prepared into the laboratory by treating manganese dioxide. Now they are asking, hmm, they are asking, uh, with hydrochloric acid, according to this equation, that is 4HCl plus MnO2, this will give us 2H2O plus MnCl2 plus Cl2. Now, how many grams of chlorine is produced if 10.95 gram of HCl react with 8.7 gram of manganese dioxide? So they are asking how many grams of chlorine is produced. So from the equation, we clearly observe that 4 mole of HCl produce how many dioxide beta? That is 4 mole of HCl required 1 mole of manganese dioxide. So by using this stoichiometric coefficient, we can easily calculate, right? Let's see the calculation. So we know the first step is the balance equation. So this is the balance equation we already have, right? Now in the second step, number of moles of each compound. So that is mole of HCl is equal to 0.3 mole. Moles of amino is equal to 0.1 mole. Now in the next step, we have number of moles versus stoichiometry coefficient, right? For example, in HCl, we have a 4 mole. So its value comes out to be 0.075. In amino the values comes out to be 0.1. So obviously 0.1 is greater. So HCl is a limiting reagent, right? HCl क्या हो गया यहाँ पे limiting reagent हो गया. I hope this is clear. Clear? Yes. Okay, so HCl is a limiting reagent. Now, calculation based on the availability of the limiting reagent. So, 4 mole of HCl produce 1 mole of Cl2, right? 4 mole of HCl produce 1 mole of Cl2. So, therefore, 0.3 mole of HCl will produce 0.3 divided by 4, 1 mole 4 into multiply by 1. So, answer comes out to be 0.075 mole. So, 0.075 mole of CO2 will be produced. So, if you want to convert this into mass, you can also convert. So mass of Cl2 obtained, just multiply the mole with the molecular mass. So chlorine का molecular mass कितना होता है? That is 71. So the correct answer is like this. ठीक है? Now let's see the summary behind this. So in limiting region, first of all, we need to calculate the stoichiometry and stoichiometry observation. So chemical equation balance करना है और limiting region को हम लोग को find out करना है. So this already we done, right? On the basis of you can try the question 1.4, 1.7, 23, 24, 36 from their NCERT exercise as well. ठीक है? Now next, we have reaction in a solution. So this is also a very, very, very important topic of this chapter, that is reaction in solution. So in this, we are going to study the different concentration term like introduction to solution, mass percentage, mole fraction, molarity, molality. So this all thing we are going to study. Okay? Okay, what do you mean by the mass percentage? What do you mean by the molarity? What do you mean by the molality and all this thing? So the first is introduction to the solution. What do you mean by this term solution? So basically, we know a solution is a homogeneous mixture. Always remember, a solution is a homogeneous mixture of two or more substances. So solution is basically, it is a homogeneous mixture of two or more substances. Now, a solution may exist in any phase. So solution किसी भी phase में exist कर सकता है. That is in, for example, in cold drink we have, bronze we have. तो कोल्ड ड्रिंक में क्या है? सॉलिड इन लिक्विड. ब्रॉन्ज में क्या है? सॉलिड इन सॉलिड. और गैसेस में क्या है कि भाई किस तरीके से हमारा एयर का एग्जांपल हो गया कि वहां पे जो हम लोगों का गैस है वो एज अ सॉल्वेंट की तरह काम कर रहा है, राइट? नाउ basically a solution are made up of two things, that is solute plus solvent. So solute are those which is present in the small amount, यानी substance to be dissolved. ये भी बोल सकते हो कि the amount which is present in a lesser amount, or we say the substance which is to be dissolved is called solute, and the substance which dissolve the other substances is called solvent, right? So solvent and solute combine together to give solution. So basically solute is usually present in the smaller amount and solvent is present in the higher amount. So this is also a very important thing which you need to learn, right? So solute is usually present in the smaller amount than the solvent. Okay. Now, so solution is equal to solute plus solvent. तो solution हमेशा कैसे निकालेंगे हम लोग? Solution is equal to solute plus solvent. So solute plus solvent always gives us solution. Now let's see the example. For example, we have a ground coffee, right? This is called solute, and the water is called solvent. And जब दोनों को आपने mix किया, they combine together to give us the solution that is called drinking coffee, right? So here coffee is in a solute, water is in a solvent, and they combine together to give the solution, right? So I hope this is clear to everyone. What do you mean by the solution? Okay, similar second example we have salt plus water. So this also give the salty water solution. Similarly, when you dissolve copper sulfate into water, they give the copper sulfate solution. So these all are the example of solution, right? Now here one important point, solute not need to be only solid in nature, right? मतलब ये भी कभी मत समझना कि solvent हमेशा liquid होगा, solute हमेशा solid होगा. They can be either, right? Solvent और solute, they like solid भी हो सकते हैं, liquid भी हो सकते हैं, gaseous भी हो सकते हैं. So they are all different types, right? चलो. So let's see the next thing. That is, the next one is mass percentage and mole fraction, right? How will you calculate the mass percentage and the mole fraction? So let's study this thing. For example, we have a concentration, right? So what is concentration basically? How will you define concentration? Because for finding concentration, we are using different method. But actually, what is concentration if someone asks? So you can say the quantity of solute present in a given quantity of solution, right? The quantity of a solute present in a given quantity of a solution is called concentration. Yani concentration can be measured in mass percentage, mole fraction, molarity, molality, and simple, right? So these all are the term in which you measure the concentration, right? So koi pucha what is concentration? Then how will you define? That is the quantity of solute that is present in a given quantity of a solution. कि फॉर एग्जांपल लेट अस अज्यूम मेरे पास एक शुगर सॉल्यूशन है, मेरे पास सॉल्ट सॉल्यूशन है, एंड समवन आस्क कि बताओ इसके अंदर कितना सॉल्यूट प्रेजेंट है. देन वी यूज आइदर ऑफ दिस फोर मेथड टू फाइंड द कंसंट्रेशन. आई होप दिस इज क्लियर टू एवरीवन. जस्ट कंफर्म वंस. Yes, everyone, give the confirmation. Is this clear to everyone? Yes. Okay, good. Now, let's see the first one, that is a mass percentage. So, what is mass percent? So, mass percent is equal to mass of solute divided by mass of solution into 100, right? So, mass percentage, how will you find the mass percentage? So, the formula for finding mass percent was mass of the solute divided by mass of the solution into 100%. So, this is the way to find the mass percent. Okay? Now, let's see. A solution is prepared by adding 2 gram of a substance A to 18 gram of water, right? So a solution is prepared by adding 2 gram of substance A to 18 gram of water. Calculate the mass percent of the solute. So you need to calculate the mass percent of the solute. So चलो देखते हैं कि क्या होगा mass percent solute का हम लोगों का, और किस तरीके से हम लोग mass percent solute का फाइंड आउट करते हैं. सबसे पहले मुझे बताओ इसमें क्या क्या दिख रहा है आपको. सबसे पहले आपको दिख रहा होगा सॉल्यूशन है, और ये सॉल्यूशन को कैसे प्रिपेयर किया गया है. 2 ग्राम डाला गया है सब्सटेंस ए को इन 18 ग्राम ऑफ वाटर. इट मींस वाटर एक्ट एज अ सॉल्वेंट हेयर and this act as a solute, right? So water act as a solvent here and this act as a solute. Now they are asking calculate the mass percentage of the solute. You need to calculate the mass percent. Let's see. सबसे पहले मास ऑफ ए कितना है, दैट इज इक्वल टू 2 ग्राम. तो मास ऑफ ए आ गया 2 ग्राम. नाउ व्हाट इज द मास ऑफ सॉल्यूशन हियर. सो मास ऑफ सॉल्यूशन इज इक्वल टू मास ऑफ ए प्लस मास ऑफ वाटर, यानी 2 ग्राम प्लस 18 ग्राम इज इक्वल टू 20 ग्राम, राइट? 2 ग्राम प्लस 18 ग्राम इज इक्वल टू 20 gram. So now mass percentage of A, how will you calculate mass percentage of A? So mass percentage of A comes out to be mass of A divided by total mass of the solution into 100%. This is how you can calculate mass percent. समझ आया? How will you use this formula? That is mass of the solute. What is the mass of solute here? 2 gram. What is the mass of solution here? That is 2 plus 18. That is 20 gram. So 2 divided by 20 into 100. That is comes out to be 10%. So this 10% is the correct answer. ठीक है? तो 10% हम लोगों का बिल्कुल यहाँ पे correct answer यहाँ पे निकल गया. I hope this is clear. Yes. चलो. Now let's see the mole fraction. What is mole fraction and how will you define mole fraction? होता क्या है mole fraction देखो एक बार. चलो देखते हैं फटाफट. Just give me a second. Yeah. Okay. So what do you mean by this term mole fraction? So basically, it is the ratio of the number of moles of the particular component to the total number of moles of the solution, right? So what is this? It is the ratio of the number of moles of a particular component to the total number of moles of the solution. Let's see. It is represented by एक्स. इस तरीके से इसको रिप्रेजेंट किया जाता है. ठीक है, तो एक्स की तरह ही बना लेना बड़ा सा. so it is represented by this. So now mole fraction of the component is equal to, what is the formula for mole fraction? Let's see. So the mole fraction of the component is equal to number of moles of the component divided by total number of moles of all the component, right? That is the number of moles of the component divided by the total number of moles of all the component, right? Let's see. For example, this is in a solution which consists of A and B, right? Maybe A act as a solute or solvent, we don't know, right? So how will you find the mole fraction? For example, if someone say, what is the mole fraction of A? What is the mole fraction of B? Then how will you calculate? So the mole fraction of A is equal to number of moles of A divided by number of moles of the solution, यानी total number of moles. So अगर आपको मोल फ्रैक्शन A का निकालना है, so just use Na divided by total, that is Na plus Nb. Similarly, if someone want to calculate the mole fraction of B, so mole fraction of B comes out to be Nb divided by total number of mole, that is Na plus Nb. Now, the sum of the mole fraction of all the compound present in the solution is unity, right? So the sum of the mole fraction of all the compound present in the solution is unity, right? Is unity. That is xa plus xb is equal to 1. Obviously, na, Na divided by Na plus Nb, Nb divided by Na plus Nb. So when you add this two, this value comes out to be 1. So the sum of the mole fraction of all the compound present in the solution is unity. So if you calculate the mole fraction of 1, then you can also calculate other mole fraction by just subtracting the value of the first from 1, right? So 1 से आप उसको minus कर दो तो अपने आप आंसर आ जाएगा. Chali, let's see an example through which we understand the mole fraction as well. So if the 4 moles of alcohol and 6 mole of water are mixed, then calculate the mole fraction of each component, right? So we have a 4 mole of alcohol and 6 mole of water and they are mixed, right? Now calculate the mole fraction of each component. So how will you calculate? So the mole of alcohol, that is Na, is equal to 4 mole divided by mole of water, that is NW, which is equal to 6 mole, right? So the mole of alcohol Na is equal to 4 mole, mole of water that is equal to 6 mole, right? Hmm? Now let's see the next one. The mole fraction of component is equal to number of moles of component divided by total number of moles of all the component, right? So we have that is XA. So number of mole of A is equal to 4 divided by 4 plus 6, that is 10. So 4 divided by 10 comes out to be 0.4. Or we can calculate the mole fraction of water, that is number of moles of water divided by number of moles of alcohol plus water, 0.6, right? So this is how you can actually calculate. So I hope mole fraction is also clear, everyone. Any doubt you can ask? Yes, if you have any doubt you can ask. Yes, no, is this clear to everyone? डन। चलो भाई नेक्स्ट चलते हैं। So next we have molarity, right? So the next term is molarity. That is, what do you mean by this term molarity? क्या होता है molarity? तो इसको देखना है हम लोगों को एक बार। तो फटाफट देखते हैं कि what do you mean by this term molarity, right? So let's see. Molarity, the number of moles of solute present per liter of the solution. That is called molarity, right? That is, the number of moles of the solute present per liter of the solution is called molarity. It's a simple formula, right? Now, let's see with an example कि किस तरीके से example से हम लोग समझ सकते हैं. ठीक है? Now, so molarity, which is m, is equal to number of moles of the solute divided by volume of the solution in liter. Now, what is the unit of finding molarity? How will you find molarity, beta, actually? So, we find molarity by using a simple formula, right? Let's see the formula. Now, the formula is number of moles of the solute divided by volume of the solution. We also write the formula like this, that is number of mole. So, we can write number of mole as mass of solute divided by molar mass multiply by 1000 and divided by mass of solvent. ठीक है? So this is the formula for finding the molarity. कि molarity is nothing but is equal to mass of the solute divided by molecular mass into 1000 and divided by mass of the solvent, right? अब देखो कैसे करेंगे इसको पूरा. So for the dilute solution, let us consider a dilute solution. So for the dilute solution, मान लो हमारे पास एक कोई solution है having molarity M1 and their volume is V1. Now on adding water, dilution means what? Dilution means adding water. ठीक है? तो आपने water को यहाँ पे add कर दिया. तो on adding water, what happened basically when you add water? So when on adding वाटर बेसिकली होगा क्या यहाँ पे वो देखो जरा एक बार. सो जैसे ही आप यहाँ पे वाटर को ऐड करोगे, राइट? सो व्हेन यू ऐड वाटर, now their molarity become M2 and their volume become V2. So we write the molarity equation like M1 V1 is equal to M2 V2, right? So this is called the law of dilution. Whenever we dilute, the molarity become M1 V1 is equal to M2 V2. तो जब भी क्वेश्चन आएगा डाइल्यूशन का, so we can use this formula as well. हम इस फॉर्मूले को यूज कर सकते हैं कि M1 V1 जो होता है वो किसके इक्वल होता है बेटा? That is equal to M2 V2. Now a very simple question we have, that is calculate the molarity of the aqueous NaOH solution prepared by dissolving 4 gram of NaOH in enough water to form 250 ml of the solution. So here we all know the mass of solute is given, that is 4 gram, and molecular mass of NaOH we all know, Na having 23 molecular mass, oxygen having 16, hydrogen having 1. So it is equal to 40. कितना होगा? 40. So that is 4 upon 40. It comes out to be 0.1 mole. कितना आ गया? 0.1 mole. Now the volume is also given, that is 250 ml. 250 ml को अगर आप लीटर में convert करो 0.25 liter. So what is the formula of molarity? That is number of moles of the solute divided by the volume of the solution. So it comes out to be 0.1 divided by 0.25, right? So 0.1 divided by 0.25. So this is the formula we have. Got it? Now everyone, आप लोग इस क्वेश्चन को एक बार फाइंड आउट करो. Calculate the mass of the sodium acetate required to make 500 ml of 0.37 molar aqueous solution. Molar mass is given and this is the molarity. ठीक है, ये molarity given है and you need to calculate mass of the solute, right? And molecular mass is also given, molarity is given, volume is given. फटाफट, you have 1 minute everyone. सभी लोग ट्राई करेंगे निकालने का. निकालो एक बार फटाफट. सभी ट्राई करो. सब कुछ गिवन है आपको. Molarity is given, volume is given, molecular mass is given. You just need to calculate the mass of solute. Find out. Yes. Chalo, I'll explain. So here the molarity of the solution is given 0.375 molar. Volume of the solution is also given 500 ml, that is equal to zero point 0.5 liter. Now molarity is equal to what? Number of moles of the solute divided by volume of the solution. So you'll calculate the number of moles from this formula. Now the number of moles is comes out to be 0.1875 mole. Now what is the formula for calculating mass? So mass is equal to number of moles into molecular mass. So number of moles is already we calculated 0.1875 and the molecular mass in the question is already given, that is 82. So it comes out to be 15.375 gram, right? That is 15.375 gram. So this is how you can actually calculate. सबका ये आंसर आ रहा था? Does anyone try? Yes. चलो. Now, the next is molality. What is molality? So it is defined as the number of moles of the solute present per kilogram of the solute. So molarity is per liter and here per kilogram. So this is the important difference between these two. Molarity we are measuring in liters volume and in case of molality we are using per kilogram of the solvent. It is denoted by a small m and the unit of molality is mole per kg. So it's a simple formula, just like the molarity. Instead of using volume of the solution, we are using mass of the solvent. Right. Now we have a question. Calculate the molality of 2.5 gram of ethanoic acid in 50 gram of benzene and molar mass of ethanoic acid is given, that is 60 gram. So let's see, it's a very simple thing. First of all, we need to calculate the mole. So mass upon molecular mass. So mass is given 2.5 gram. Molecular mass is also given 60. It comes out to be 0.0417 mole. Now mass of solvent, that is benzene. How will you calculate the mass of solvent, beta? So this is already given in the question. That is a 50 gram of benzene, yani 0.05 kg. Now molality, we are using the formula, number of moles of the solute divided by mass of the solvent. So 0.0417 mole divided by 0.05, this comes out to be 0.834 mole. So this is the formula for calculating the molality. I hope this is clear. Done? Yes, everyone. Any doubt? No? चलो. So this is all. One question for you guys. आप लोगों को calculate करना है. The density of the 3 molar solution of NaCl is given. Calculate the molality of the solution. So here density is given, right? So everyone need to try. And what formula actually you need for calculating molality? तो क्या चाहिए? Number of moles upon में mass of the solvent. So by using this density, right, you need to calculate the mass of the solvent, right? Then only you are able to calculate this. सो दिस इज फॉर ऑल ऑफ यू. ये आप लोगों को करना है सॉल्व. ठीक है, आप ट्राई करोगे इजीली सॉल्व हो जाएगा. कोई डिफिकल्ट ज्यादा है नहीं है ना. नॉर्मली आप इसको सॉल्व कर सकते हो. ओके. चलो. मैं थोड़ा सा हिंट देता हूँ इसमें, कहीं इससे कई बच्चों को प्रॉब्लम हो तो मैं थोड़ा सा हिंट दे देता हूँ. सो एज्यूमिंग वॉल्यूम ऑफ द सॉल्यूशन इज 1 लीटर, राइट. मान के चलो 1 लीटर का है. मोलारिटी ऑफ द NaCl इज कितना गिवन है? 3 मोल पर लीटर, है ना. तो मोलारिटी इज ऑलरेडी गिवन, दैट इज 3 m, एंड डेंसिटी इज गिवन 1.25 ग्राम पर मिलीलीटर. सो डेंसिटी 3 मोलर सॉल्यूशन का मतलब ही होता है कि 3 मोल है इन 1 लीटर. तो वहां से साफ साफ पता लग गया कि वॉल्यूम ऑफ द सॉल्यूशन क्या है इसका? 1 लीटर. अगर 2 m लिखा होता तो 2 मोल इन 1 लीटर. 4 लिखा होता तो 4 मोल इन 1 लीटर. तो 3 m लिखने का मन है, मतलब है कि 3 मोल प्रेजेंट है 1 लीटर में. So assuming volume of the solution is equal to 1 liter, molarity of the NaCl solution कितना हो गया? 3 mole per liter. And moles of the NaCl कितना हो गया? 3 mole. Now also mass of the NaCl कितना होगा यहाँ पे जल्दी बताओ. So that is 3 into 58.5 gram. That comes out to be 175.5 gram. कितना आ जाएगा? 175.5 ग्राम यहाँ से निकल के आ गया. That is mass of the NaCl. Now density is given कि 1.25 ग्राम है. तो बेटा डेंसिटी क्या होता है सबको पता है ना. डेंसिटी इज इक्वल टू क्या हो गया? जल्दी बोलो. डेंसिटी इज इक्वल टू वॉल्यूम और मास का रिलेशन है, ठीक है. तो डेंसिटी कैसे निकालते हो हमेशा? दैट इज मास अपॉन वॉल्यूम. तो यहाँ से अगर मुझे मास निकालना हो तो मैं कर दूं डेंसिटी इंटू वॉल्यूम. हम्म. तो ये रहा डेंसिटी, ये रहा वॉल्यूम. तो यहाँ पे मास ऑफ द सॉल्यूशन आ गया. सो मास ऑफ द सॉल्यूशन अगर इतना है तो सॉल्वेंट का कितना होगा? सॉल्यूट का -175 माइनस कर दो. तो जैसे आप माइनस करोगे आपका आंसर निकल जाएगा मास ऑफ सॉल्वेंट 1074.5. बस सिंपल. अब नाउ पुट द वैल्यू मोलालिटी में. नंबर ऑफ मोल्स ऑफ सॉल्यूट पता ही है और मास पता ही है, तो 2.79 मोल कम्स आउट टू बी आंसर. मैंने पूरा ही बता दिया. ठीक है. चलो भाई. तो हम लोगों ने ये सारा समरी हम देख लें एक बार फटाफट. तो क्या किया? मास परसेंटेज पढ़ा, मोल फ्रैक्शन पढ़ा, मोलालिटी पढ़ा और मोलारिटी पढ़ा. किसी भी बच्चे को कोई भी डाउट हो तो यू कैन आस्क फटाफट. मैं एक पोल लॉन्च कर रहा हूँ, सभी को पोल फिल करना है. एवरीवन स्टार्ट फिलिंग द पोल.